Hello, and welcome to our webinar, How to Scale Production Machine Learning in the Enterprise. I'm Abbie Lundberg. I'm a business technology researcher and writer and president of Lundberg Media. I'll be moderating today's discussion. So today's topic is certainly timely. Organizations are moving quickly from asking if AI is right for them to exploring how to make the most of it for their customers, shareholders, and employees. In today's webinar, we'll explore why many organizations are struggling to put machine learning into production at scale. We'll talk about what it takes to build, scale, and deploy enterprise machine learning solutions and make them both repeatable and predictable. We've got two terrific speakers, Tom Davenport from Babson College and Alex Breshears from Cloudera. They're going to talk about what challenges to expect with enterprise-grade machine learning, integrating AI into the company's roles and functions, what a production ML workflow actually looks like, and how to architect for repeatable machine learning production. So we're really lucky to have Tom Davenport with us today. Tom is the first person I think of when it comes to defining leading practices and getting the most value from data and data technologies. He is the President's Distinguished Professor of Information Technology and Management at Babson College. He's also the co-founder of the International Institute for Analytics, a fellow of the MIT Initiative for the Digital Economy, and a senior advisor to Deloitte Analytics. Tom has authored one or more of the key defining books for every stage in what has now come to be called the digital economy, going back to when we were talking about information and knowledge management. He's written over 250 articles for Harvard Business Review, Sloan Management Review, the Financial Times, and many other publications, including CIO, where I had the pleasure to serve as his editor for many years. His academic credentials are equally impressive, with a PhD from Harvard and teaching gigs at the Harvard Business School and other prestigious colleges and universities around the country. Tom, welcome.
So my role today is to sort of talk about the context, why organizations would want to sort of greater institutionalize AI, how machine learning is starting to take off, and how we're really moving beyond the relatively artisanal approach to AI that we have historically been using, that requires a lot of labor and a lot of time and so on. So I'll provide the context, and then Alex will provide some of the solutions to that context. I've been working on the state of enterprise AI for a while with Deloitte and some other institutions. I've done a number of surveys with Deloitte. My data suggests that at least as of the end of 2018, maybe a little bit higher now, but 20 to 25% are of organizations, large organizations, are aware of AI and doing something with it involved technology or another. I saw a recent survey suggesting globally it was about 30% now. So this is certainly not just a US phenomenon. A few of those companies might be described as AI first, or what I referred to in analytics as competing on AI. They have built their strategies around the technology, but most are more dabbling, I would say, with a lot of pilots, relatively few systems in full production, and not really enough of them. I think that's one of the challenges that we have with AI, and I think this webcast will help you think more about putting systems in full production deployment. Companies want to do a lot of different things, and I'll talk about what the objectives for using AI are, but the one that is most discussed in the press is automating jobs. In general, I have found that to be a relatively low-level objective of organizations, but in the most recent survey I did with Deloitte in 2018, 63% of managers in the US said they want to automate as many jobs as possible. So, and in order to cut costs. So I think we certainly can't be complacent about that particular issue. In general, I found that moonshots with AI, very large, ambitious projects like, curing cancer is the most prominent example, have not worked out terribly well. But low-hanging fruit projects are much more likely to be successful. But if you want to get substantial benefit from AI and even organizational transformation, you have to do a lot of them, because AI is a relatively narrow technology focused on particular tasks. Companies have faced various challenges. I'll talk more about these, but implementation of their pilot systems, integrating it with their existing systems and processes, getting talent, of course, and having the right kind of data. Large firms are moving rapidly to create AI management infrastructure. So I don't think you can sort of be a fast follower in this regard. And as I suggested, I think we need to move as as an economy, as a society, beyond the sort of more artisanal model creation by relatively few data scientists. So we thought we'd start with a poll question about how much AI is taking place in your organization today. Can we bring up the real question? There we go. So please, if you would, note just how aggressively your organization is using AI. Is it something where you have lots of applications in production, where you have a lot of applications underway, but maybe a lot of proofs of concept and pilots, where you're exploring it, maybe one or two projects, not using it at all, but plan to do so in the future, or you just wandered into this webcast by accident and you have no plans to do it at all in the future.
And then over on the GoToWebinar panel, there's a poll thing there. If you click on the arrow to expand that, the questions will be there.
Okay, so the numbers are in, and it looks like the modal category, the biggest category, is exploring AI, which I think is consistent with the rest of the world. About 7% or so might be described as sort of AI first, or really aggressive with it. Roughly 20% have multiple applications underway. 24% not doing it now, but plan to, and let's hope you remember what you learned in this webcast today when you get around to it, and 7% say, no, we're never going to use that stuff, but I'm glad you're curious about it anyway. Okay, so the thing about AI is it's not really one technology, but a variety of them, and I think it's quite important to understand what the different types are and what they do generally. Probably the single most popular technology is some form of machine learning, which also includes the next category down, neural networks and deep learning. Machine learning, statistical in nature, uses a lot of data. You train models on data and then apply it to situations where you don't know the outcome and you're predicting it. Neural networks and deep learning are relatively complex forms of that. Natural language processing and generation are more applications, but are very popular ones. And sometimes they involve semantic language technology. Sometimes they involve machine learning. Rule engines, may be given up for dead, but my research suggests about half of US organizations have some rule engines underway, and they have certain virtues like explainability and so on that many machine learning models don't. And then you have these automation-oriented tools. Some people don't classify them as AI, but I generally do, and they're getting smarter all the time, although historically they're not the smartest AI technology. But robotic process automation and various forms of digital workflows, automation of various types, and IT and a variety of functions, increasingly combined with things like machine learning. And then I think overall, you're seeing a lot of combinations, and we'll see more of these. Perhaps all AI applications in the future will involve a whole set of technologies, and we won't have to talk about these components because every tool will have many of them. So in terms of what technologies organizations are using now, in this latest Deloitte survey that I worked with them on, 63% said they were doing some form of machine learning. Who knows if that includes deep learning, which 50% said they were using. That is the biggest increase from the previous survey year. 62% said some form of natural language processing, maybe for a chatbot or for some sort of intelligent agent. That also increased. And robotic process automation was listed by about half. That actually went down from the previous year, but I think it's sort of random variation, or maybe people not understanding the question, because it's a very hot category right now, and all the vendors who do it are growing very rapidly. So what are people trying to do with this? You see the biggest category in terms of benefits of AI are product related, enhancing current products and services. And you see that in financial services, where wealth management products get enhanced. You see it in certainly tech, where almost all popular tech products now, Google, Facebook, etc., have big AI components. And then just below that, you see sort of what I call the kind of analytics on steroids benefits, improving internal business operations, and then decisions just below that. The same things we did with analytics, only, probably more so, because AI can get you, more granular, using more data outputs. Pretty low, as you see in this list, is reducing headcount through automation. So as I suggested, not often an objective, but then you have this issue of people admitting, yeah, we're gonna automate a lot of jobs when we can. And you also can see from this sort of which is growing, hasn't really changed that much between the last couple of years. So what challenges do organizations encounter? Implementation, broadly speaking, is a big one. I interpret that as, how do you get a production deployment out of some of these pilots? When we go into production, that means we're changing people's jobs. We may require some new skills. Probably there's going to be some of that second bar in there as well. We're integrating it into existing roles and functions and processes and systems and so on. Data issues are, of course, big, including things like data privacy, but just, getting the right kind of labeled data to teach machine learning models is a big challenge. Some people mention cost, and then skills a little bit lower, and business value measurement, the lowest in this list. As I suggested, companies are moving really quite rapidly in this space to create AI management structures. I think, I find it a little hard to believe that all of these are true, perhaps a little bit exaggerated, but more than half said they have a process for moving prototypes into production. That could be something they develop with their existing IT systems. More than half have an implementation roadmap. 45% said they have senior executives as AI champions. I have to say I haven't seen quite that many in the companies that I work with. 37% said they have some kind of COE, Center of Excellence, for AI, and 37% a comprehensive strategy. Again, I haven't seen quite that high a percentage, but at least people seem to think that they have all of these things, which is interesting in itself. So as I suggested, we have generally believed that if we're going to do AI, we have to have data scientists or AI engineers, AI specialists, broadly speaking, to create all the AI models that organizations need, and there just aren't enough of them, frankly. I mean, for my last book, I was looking at how many of these were organizations seeking, and I think at the time Amazon had 700 open jobs for AI specialists. So clearly, we're not churning them out at the rate that would make that happen. The interesting angle on that issue is that we're starting to see some tools that allow democratization of it. People refer to it as automated machine learning or auto ML. It lets, quote, citizen data scientists, people who are quantitatively oriented, but not necessarily terribly familiar with AI, and all the different algorithm types you can use in machine learning, to analyze their data. The system will figure out which model works best, and in many cases will do things like analyze different types of features for feature engineering, will transform your data for you, will even explain which features or variables are most prominent in your model. So these systems typically need some sorts of guardrails to ensure that users don't get into trouble, for example, overfitting models, but most of them do have that. I did some research a year ago or so on this issue. One of the companies I talked to was Royal Bank of Canada, and I had a pretty senior manager who was saying to me, look, I can have a data scientist who knows all about algorithms and models, doesn't know that much about my business, maybe doesn't even care that much about my business, doesn't know my customers, etc. Or I can use one of these automated machine learning tools and have them be used by quantitative analysts or business analysts types, and they know my customers, they care about my business, and they can also do similar modeling. He said, frankly, I'll take the latter. So I think it'll ultimately be a tool for both data scientists and citizen data scientists, increasing the productivity of data scientists and maybe shifting some of the load onto people who are not, PhDs in physics or something like that. We also need to sort of think about this as an industrialized activity, not the kind of artisanal activity I mentioned earlier. So complex business environments, particularly in very data-intensive industries like financial services, they need a lot of AI models. They need to be created and updated with new data, retrained on new data on a regular basis or whenever they stop predicting well. As I said, automated machine learning tools can help data scientists improve their productivity. And sometimes people refer to this as ML ops or model factories, where you create literally thousands or tens of thousands, in some cases, of models. But more and more, I think we also need to monitor and update the models continuously as we get new training data. The secret behind machine learning is that typically machine learning models don't learn continuously. They have to be retrained by human intervention. But there are now some tools that let you do continuous learning, and I think we'll see a lot more of that. Just as one example, I mean, Cisco Systems I've been looking at for years. They have these sales propensity models that predict what Cisco products and services a customer might buy. They started with a handful of models every quarter, maybe 20, developed, by a lot of data scientist types. Now they do 60,000 every quarter based on 160 million companies that they have in their database, developed in what might be called a model factory. They've increased by 10,000 the number of models they use, with only a tenfold increase in data scientists. And you really could not even consider doing that without some industrialized tools, automated machine learning, automated refitting of models, and so on. So in general, what I tell companies, how do you create an AI advantage? Think big, but start small. Think about how AI is going to transform your business, but start with pilot projects, less ambitious goals, but combine them to really have a transformational impact. Develop a pipeline to make sure those projects go into production. Skill out means start retraining your people. I think this is clearly going to I don't know if it's going to lead to large-scale job loss, but it is certainly going to lead to large-scale job change. And when people ask me, am I going to lose my job? I say the only way you're going to lose your job is if you refuse to work alongside AI, because I think we'll all be asked to do that. Develop some approach to democratizing and industrializing the field. Increasingly, particularly if your work involves consumers, you need to put some sort of ethical framework in place and a governance structure for that. And if you want AI to advance, I think you've got to put somebody in charge. So with that, I will give up the presentation to Alex.
Thank you, Tom. That was, you gave us a lot of food for thought. We're already getting some questions in, which we'll get to after Alex's presentation. But first, I'd like to introduce Alex as our next speaker. Alex is Senior Product Manager for Machine Learning and Data Engineering at Cloudera. Alex is a self-described tech head who loves innovating and solving problems. And that makes him perfectly suited for his current role, where he leads product management for Cloudera's production machine learning offerings. These products enable customers to run hundreds to thousands of ML models at scale while meeting enterprise needs. Alex has held positions in engineering and solutions engineering at Cloudera, and prior to that, he worked to develop, implement, and maintain marketing and loyalty systems at both SuperValu and Walmart. Alex, welcome.
Hey, thank you so much. I wanted to go through a series of things that we're seeing within our customer base for folks that are trying to solve machine learning, talk about some best practices and some of the ways that our customers are trying to solve these particular pieces. As far as some background information goes, and this is probably not new to a lot of folks, but this is a graph or a diagram, I should say, out of a paper that Google wrote some time back that's talking about the hidden technical debt in machine learning systems. And what I find really interesting about this and where I would center your eyes is in that small black box there that is the machine learning code. And what's interesting about this, and not to over trivialize the work that goes into figuring out the appropriate model, figuring out the mathematical fit for a particular model, et cetera, what's interesting about it is it's actually a very small piece of the entire process. It's actually, and compared to the rest of it, a very small, a very insignificant amount of it. There's obviously a lot of work that goes into creating models, but what's really difficult is all of the surrounding infrastructure around data collection, feature extraction, data verification. Tom talked about some of the issues folks are having on the data management side, but there's also a lot of really interesting things when it comes to productionalizing machine learning models. So what type of resource management, what type of serving infrastructure, all of that. And what we find it really interesting that folks that are solving this problem properly is instead of over fixating on the ML code portion of this particular system, instead they are actually working on trying to create an automated system that surrounds this and allowing folks to focus as much on solving that problem and not this other infrastructure. And this will make a bit more sense when I go through this, but this is an interesting background that Google has realized that the hard part is actually the surrounding part of the machine learning process. It's also important if we talk about productionalizing models, what a model is. There's many different definitions of this. And when you look at productionalizing a model, Cloudera tends to look at it from a point of view of it is anything and everything that is contained that allows you to take data in the form of inputs in the form of features usually, and then everything that is needed, whether it's the mathematical model, the actual code itself, maybe there's business rules, sometimes there's rule engines as a part of this, and ultimately what this is doing is spitting out a prediction and a series of exhaust that is required for things like monitoring, etc. When we're talking about productionalizing models, this is what we mean is basically anything that can take many different forms, whether it's a Python program, a TensorFlow model, etc. Anything you need to be able to create predictions based off of data that is being inputted from upstream systems. And these are ultimately being consumed downstream, whether it's a user, it's an actual application, maybe it's an internal system, etc. It is a way to be able to embed machine learning into your business processes. It's also important to talk about the overall machine learning workflow. Folks tend to think of data science and machine learning as these two boxes here, which is the data science and model training, which is all around creating these models. So How do you make sure you get the right data? How do you apply the right mathematical algorithm for it? How do you figure out the training data that you need to use? All of that fun stuff. That is where folks tend to think of machine learning and data science. What's interesting about it, though, is there is a magical moment when the data scientist and the business owner says, you know what, this model is ready for production. I've tested it out. I've realized that it is solving my problem. And this is where machine learning operations type things tend to pick up. So you need to actually package all of that stuff that we talked about a second ago. So the actual mathematical representation, the code that is required, and get that into something that you're ultimately put into production. So you need a capability for that. You also need a capability for being able to deploy models. And this is usually an automated activity, but a way to be able to move that from your development environment to production. There's also a capability that we call serving. So if you're actually providing predictions, you need a way to be able to provide those predictions to folks. So you often need a serving infrastructure for doing so. And then what's interesting about this, and probably arguably most important, and Tom touched on this a fair amount, is the monitoring capability that is needed. What's interesting about models is they are both software, but they are also doing predictions on the world around them. And what's important from a monitoring perspective is you not only monitor the software portions, which are pretty obvious. Is it up and running? Is it throwing out errors? Is it providing the predictions in the time frame that I need to? But also, how is it predicting the world around it? This is often represented in concepts like drift or accuracy, etc. And you need a capability to be able to understand how these models are performing on the functional level so that you can choose to retrain them. Maybe you need to completely rebuild the model, etc. And when you have this, you end up creating a closed loop ML system, allowing for either automated or human driven changes for models and updates, etc. But that's all well and good. If you can get models to production, you can monitor them, you can make sure they're healthy, retrain them, all that fun stuff. But what our customers are saying is actually they don't want just a couple models in production. Tom mentioned this a second ago too, but folks are wanting to embed these literally everywhere in their business. And when you do this, you have a very interesting governance problem. And what's interesting about that as well is a lot of these governance issues tend to be based off of the underlying data to begin with. So machine learning, at the end of the day, is all about data. And a lot of the governance rules like data access, et cetera, drive a lot of the rules around that. So having a governance platform that enables model security that is based off of data, so who has access to models, who should be able to deploy them, et cetera. A series of governance rules very loosely related to the security portion, but what workflows should models go through before being deployed. And then finally, there's concepts, and from a governance perspective, that tend to boil up in the form of a model catalog and a features catalog or feature store. So this allows for a lot of reuse of models, understanding what models exist, what features go into those models, vice versa. And this allows for a number of things, including things like compliance and regulatory reasons. So understanding why models are predicting the things that they are, what's driving that, and also a series of productivity benefits. So the ability to know if my peer over here developed a churn propensity model, can I reuse that? Maybe I can augment it, that kind of thing. So I'm not completely reinventing the wheel. So from our customers are ultimately coming to us in the marketplace and saying, hey, what is needed from a production machine learning perspective? And everything in green is effectively where folks are starting to realize that they need capabilities around. And I want to talk about a little bit of how customers are solving that. So just to summarize some of the key challenges, so the data management, and I touched on this briefly, is a first order problem. You have to understand what data exists in your enterprise. You need to have very clear governance around that, who has access to that data, what is good data, what is clean data, etc. That is a first order problem that has to be solved before you can do machine learning properly. For folks that are doing production ML, and it sounds like based off the survey Tom did, that folks are primarily in like an exploratory proof of concept phase. And the folks that are in that phase and implementing models into production, These are basically very custom IT projects. So you're having to procure some hardware. You need to then go through a software development process, figure out how you can embed that model that the data scientists prepared within the business or within the particular application, etc. This does not scale is ultimately the problem here, and that's very much related to this third bullet, which is that's fine if you only want a couple of these in production, but folks literally want them everywhere in every part of their business and every part of their product. And what this will ultimately talk about in a second is what's interesting about this, and the Google paper really reinforces this, is a lot of the work around productionalizing an ML model is actually very repeatable. It's basically some infrastructure, some serving infrastructure, some deployment capabilities, etc. And what we're finding is folks have found ways to repeat a lot of the surrounding stuff around that. So the way folks that have done this correctly, and there are a few of our customers in that kind of that top bucket where they're AI first, have built a platform for this. And I want to talk about what this platform actually looks like. So the key requirements that they're trying to solve for this is the serving infrastructure I talked about. So having a place to be able to serve predictions at scale. This means both the number of models and the number of predictions that are happening. You needed to operate these models. So these things are providing business critical applications that are both from a revenue and cost perspective. That needs to be handled properly. And then we spent a fair amount of time talking about governance, but you need a way to govern a lot of these models and processes. So what does an actual architecture look like? I know this is a bit of a busy slide, but what we've found that folks that have done this and have done it pretty independently, interestingly enough, have built something that looks roughly like this. So you tend to have a central, or let's actually start up here at the model development environment. So you have a place for being able to develop models, to train them, understand what data is useful, and where you can also build models. So how do you package them up in a way that can be then deployed? And then you end up having a centralized serving infrastructure that is primarily doing two types of models. So models can do all kinds of stuff. We tend to see both a batch scenario, so where you score an extremely large amount of data and then ship it off to a different system, or maybe a report or something along those lines. But we're starting to see increasingly more real-time models, and these tend to be in a form that we're calling function as a service, where you have an application, maybe a data stream, or even a user where it's calling this in a real-time way, sending the features over, and then it will send the prediction back for consumption downstream. And what this provides is a centralized way of managing this, and makes it easy to update models, to redeploy them without affecting the system that is consuming them, because these things are living software and they need to be updated very frequently. So a lot of automation is definitely useful from that perspective. What's also interesting from a monitoring perspective is you need to consume the prediction. So what is actually being outputted from these, oftentimes input as well. So what is going into the models. And sometimes you want to have various metrics that you want to track about this. So folks have built a centralized monitoring solution that basically captures all of this information. And this is very much of an operations tool in the sense that someone is effectively on call for these models. So they have a place to troubleshoot them, understand, and be alerted when things are getting out of bounds, so that they can troubleshoot, maybe escalate to the data scientist who created these, etc. And then finally, there is a series of metadata repositories in the form of a model and feature store that, and done properly, integrated into the data and data catalog, create a governance solution. So this is a place to store all of your information about your models and the features, the data that it's using, etc. And then finally, there's this custom models box that you can see here. Is what's interesting about this central serving infrastructure is it can probably handle 90+% of use cases, but there are use cases with models that just don't make sense to have in this central infrastructure. And what you want these this model catalog, et cetera, and this operations tool for monitoring models is it needs to be pluggable in the sense that you can have models, regardless of where they're deployed, have a central place for managing these. Again, it makes a lot of sense to put a lot of use cases in a central infrastructure, but that's not for everything, and you don't want to break your governance and operations tool. So if I were to really summarize, it's like a repeatable, automated way of deploying these models and managing them. And then finally, and this is my last slide, is some of the key functionality when you're thinking through these types of systems is you should have a fully automated build and deploy process. So we mentioned this a few times, but a lot of the plumbing for models is very repeatable. So you can have very straightforward code that is doing the prediction. And there's no reason why you can't automate getting the right infrastructure, building the models, deploying them, and that, et cetera. These models are very similar in that particular nature. It's also important to have a cloud native serving infrastructure. The primary reason for this is you need quick deployments because you're doing them on a very regular basis, much more than normal software. And also because they are providing predictions for downstream systems, you want demand-based resources. So having an elastic infrastructure that allows you to scale up and down saves costs and enables the appropriate SLAs for these systems. It's also important to have a centralized metadata repository. You need a single place to be able to govern your models. And it's also critical because a lot of those governance rules are driven by the data itself, that it integrates to the data catalog. It is also important that you have a centralized monitoring system. You tend to have a group or a small number of people that are responsible for making sure models are healthy, and it's important that it goes beyond the normal technical aspects of these models and can monitor the mathematical or the functional nature of these. And then finally, it is really helpful from a data science productivity perspective to allow integration into things like AutoML libraries and tools to help folks be able to be more productive and figure out the right model. And with that, that's actually the bulk of my content, and I will transition it over.
Great. Thank you so much, Alex. That was terrific. So let's turn on our webcams now and get to the Q&A portion of this. We've had some great questions come in. We had a few that were around really, so if so many people are in the sort of proof of concept or piloting stage, we had a number of questions around, okay, so how do you get started? And so Tom, the first question is for you. You identified some key challenges to getting up and running with enterprise AI. Is there a common problem that you see companies wrestling with that can either be jury-rigged or set aside while they gain some momentum? So are there problems that you just sort of have to sort of push them aside?
Well, Abbie, I think the most common problem for getting started is getting data to train your models, assuming that the AI you're focusing on involves machine learning, and you may have to have some human effort to label some of your data. You might have to label some images. For example, you could hire some people externally to label some of your images for you if that's the kind of problem that you're trying to solve. Maybe you have a subset of your data already where you know the outcome in healthcare. Did the person get diabetes, if that's what you're trying to predict? But data is usually, I think, the hardest part, and the more data, the better, but you can do some machine learning models with a relatively small amount of data. It's just unlikely to give you the accuracy that you want. And if you're talking about deep learning, that tends to involve a lot more data. So I would say start with some of the relatively simple types of algorithms and start with the data that you have.
Great. And Alex, the next one is for you from Annette. What is most crucial when trying to scale a proof of concept in a non-data driven company?
It's a really interesting question. And I think it's to reinforce Tom's point is starting off with trying to become data driven. But I think more importantly, instead of trying to go and have a big bang project where you're trying to capture all the data that you've ever had without specific use cases, and then build this infrastructure, is actually start with some core business problems, one or two use cases, and then have a vision for where you want to go. So you have this platform in which you want to build, but do it in pieces. So build a particular use case in a pluggable, scalable way, and then start iterating on that. And then what ends up happening when you do that is every time you do one of these projects, it becomes cheaper incrementally to do so. So if you start off small, have a use case, but know you're building a repeatable infrastructure for doing this, then you're able to get started with that. And then eventually you end up having data that is reusable because you've used it in previous projects. You have of course, the infrastructure, et cetera. So that ends up making it a lot easier if you start with a specific use case. And frankly, it also proves value in what you're doing, because a lot of folks will say, well, we spent $10 million or whatever on this project. How much am I actually getting out of it? Showing real business value helps with a lot of that from my perspective.
Abbie,
Great.
can I steal your role for a second and ask Alex a question?
Sure.
So Alex, the companies that you're seeing who are really building these platforms and building a real production environment for machine learning, are they mostly financial services and tech companies, or is it across a wide variety of industries?
It's across all industries. There's definitely a lot of leading from a tech perspective, but financial services, healthcare, telco, retail, basically everyone is interested in this. I would say that, and frankly, there are folks in every industry that are further along than others. So I definitely would not pinpoint any of these type of initiatives to any industry.
Interesting.
So we did have a couple of industry-specific questions, however. So one had to do with financial services. And Tom, I think this one might have been for you, but you can both answer. And this was from David. Can you speak more about the recommended governance structure for AI for firms and financial services? So the context is that banks already have model risk management and governance regulatory requirements in the US and the EU. Would this framework also work for AI governance in banks, and would it work for other industries that have consumer customers?
I think that most of the banks that I have worked with are viewing AI-driven models as extensions of their existing analytical models. There are some special challenges related to certain types of AI that financial services firms really have to wrestle with, specifically transparency. I mean, some of these complex deep learning models are really not transparent at all to either someone inside a bank or a regulator, and so for the most part they're not able to use those models. I think the smart banks, and I talked recently to aggressive analytics and AI users like Chase and Capital One, they're trying to work with regulators, trying to educate them, trying to see are there ways that they can start to use these more complex models, which are often great predictors of whether you'll pay back your loan or not. Can we start to use them even though they're not very transparent and understandable by anybody? Are there ways that we can sort of shortcut to using them? And they're not there yet, but I think some progress is being made.
Is there a typical, I don't know if there's a typical machine learning deployment, but the question is there a sort of typical size of a model portfolio? Like, is there a place where people should be saying, okay, we're getting to the right place? Alex, you want to take that one?
I wouldn't. I think it's over arbitrary to just say you need X number of models within your business. I would say that generally speaking, measured in the singles or tens is probably pretty low because they tend, like I mentioned a second ago, they tend folks that are doing this AI first are trying to embed them in every part of their business and virtually every application and that kind of thing. And when you look at it from that perspective, it tends to be a large number of them. And that's the way I would try to look at it, is actually better of how AI is helping your business overall. And that's what's most important versus the number of models. But usually speaking, it's measured, like, done right, in the hundreds, and folks are starting to look in the thousands as they start rolling out these and the broader part of their business.
Well, and you can get more over time as you start to, a place like Cisco, they started out saying, okay, let's develop this model for all of our products. And then they said, well, not everybody has similar propensities to buy across all of our products, so let's start to get more granular. And then they got more granular by geography, and they even started to get more granular in terms of what individual role within an organization might be most likely to buy. So you don't have to start with thousands of models. You can just expand to it over time.
So you both talked about the importance of fostering AI integration throughout an enterprise, and the importance of not just taking a piecemeal approach. So how do you do that? Do you have any particular recommendations, particularly for early adopters of AI?
Yeah,
I think involves putting somebody in charge, as I said, a center of excellence. You noticed on a lot of Alex's slides, the word centralized appeared pretty often, and that doesn't happen without some organizational structure that at the centralized level that's overseeing AI and how to put it into the organization.
Yeah, I totally agree. It's have the vision, but start small. Is most simply, like, you need to have a group that, or someone that is thinking about the centralized capability. Is maybe one way to put it, and competency within a company. But still, like, just start building the competency over time by using real use cases. That's the most basic way I would describe that.
And in a lot of cases, I see companies combining AI with existing analytics groups. I mean, there's machine learning is basically predictive analytics at its core. Obviously, you can get into more complex algorithm types and so on that are typically used in predictive analytics, but can be a pretty straightforward extension of what you may have done with analytics in the past. And a lot of companies have somewhat centralized analytics groups, so I think it's often better to add AI to that capability if you can.
Right. So Hector wants to know if you have any recommendations or examples, I guess. I'm sorry, this is from Badri. Do you have any examples of companies that are applying AI incorrectly? And I'm not sure if he's talking there about the sort of enterprise approach that they're taking, or about the actual application. I'm going to guess that it's the latter. So where have you seen examples of AI gone wrong? And then on the flip side, do you have an example or two of companies that have gone about it the right way? That's a big question.
Yeah, to answer the last one first, like the right way, is again that repeatable infrastructure and process, so that you have basically a data scientist or a machine learning engineer can write their machine learning code, and that's it. And then they have a process where they say, hey, I want to deploy this. And then it gets picked up. There's an automated process for it. There's often humans involved in making sure that it's the right thing to be deployed. Of course, all of the governance rules that I talked about and that kind of thing. And on the converse are folks that decide to do it in a custom way. And it ends up causing problems because if the data scientist is trying to work with a machine learning engineer to deploy these models and say a custom IT project, what happens in that scenario is there's a lot of lost context between those two, and maybe the code needs to be rewritten because it was in a language that's not IT supported. Those kind of scenarios end up coming up a lot. That's where they've done it wrong from just like the process perspective. I think even in a worst case scenario is where, and Tom kind of hit on this a little bit in the financial services question, is when you're creating models that no one can explain. And then they start getting them in trouble from a regulatory perspective, or frankly, they just don't know what is going on from a business perspective, and they can't properly correct these. So having tools and processes for documenting your models, having that model catalog to be able to put these things into a place is something that is very important. And folks that ignore that end up having this unwieldy problem of like, I have no idea what models exist. I don't know what they're doing. I don't know who owns them. And it becomes kind of this mess within your company.
I would I certainly agree with what Alex is saying, but I would address it from a slightly different perspective as well, that most of the overall AI strategy problems I see, it's because the organizations are either overly ambitious or not ambitious enough for their capability. I mean, even if you take an organization like Amazon, the great bulk of their AI activity is in kind of day-to-day, picking the low-hanging fruit, making the engine hum a little more effectively. Granted, they do have some very ambitious projects like, you know, the Amazon Go stores that use machine learning to figure out what you're buying in the store without having to go through the point of sale. It's taken a long time to roll those out, and one might argue it's the world's most expensive convenience store, but still, for an organization like Amazon, it probably makes sense to be that aggressive. Another organization without as many capabilities, that kind of moonshot would not make sense, like the curing cancer problems that organizations like MD Anderson had early on. And then you have some organizations that just aren't ambitious enough. I worked with one of the world's leading, world's largest insurance companies, and talked, well, what's your approach to AI? Oh, we've got robotic process automation pilot in the finance part of our business. I mean, clearly, it's a data-intensive industry. They've got the scale. That is not ambitious enough to really make a lot of progress, and I think they're going to be left behind as a result.
We have a bunch of questions around data. So I'm going to throw a couple of them out there. How big is a data acquisition problem? You know, how hard is it to get clean, usable data? And then as a follow-on, why do firms lose interest when they learn about the effort to get and clean the data? So I'll hold the next one for after you answer this one.
Well, you know, this is not a new problem. It's been, as Abbie knows, I'm sure you were writing about it in CIO when I first started working with you. It's always been an issue when we want to start to analyze data. We see it's of low quality, or there's not enough of it. You know, I think the only good news is that AI is starting to be able to help us a bit in that regard, and we can use these probabilistic matching tools that help you integrate data. There's a little bit of work that's now being done in creating faster approaches to improving data quality with AI, but it's been a bugaboo for a long time. And if you are easily discouraged by data issues, then you're probably not going to be successful with AI.
I just looked at the clock and I can't believe we're almost out of time, and we have time for one more short question. And so rather than ask, I'm really sorry we're not getting to all of your great questions. Rather than ask another data one, I'm going to ask one I think that was probably pitched to Alex. When you were talking about the centralized infrastructure, are people, what proportion of companies are developing their own centralized infrastructure, or are they using off-the-shelf tools, serving infrastructure, feature store? Do you have examples of companies that are building that out now?
Yeah, that's a really good question. I think based off of a lot of the analysis that I spend, frankly, a lot of my time on is trying to figure out what stuff exists in the marketplace for this. And from my perspective, there are pieces of what I've described in various levels of maturity. There are things like Kubernetes is being much newer from a serving infrastructure as an example. There are niche vendors that are trying to solve things like the model catalog and that kind of thing. And folks that have done this, generally speaking, and are successful, interestingly enough, have built their own because what they've found is it's either build their own or duct taping a series of these off-the-shelf things together. And what folks are saying is they really need something that is more holistic and best integrated together is really what it comes down to. A lot of the folks actually, interestingly, in the financial services industry, because they've been doing quote unquote machine learning for some time via their models for risk, et cetera. So they have experience in this, and then they've learned to create these repeatable systems. And again, it's either completely custom infrastructure. I know of a large insurance company that has done that to other folks that have effectively integrated existing systems, but it comes with a significant amount of challenge in both of those scenarios.
So we do have 1 minute left for that data question, and there's a two-sided question here. One person asks, so what do you recommend when it comes to a small business? Because small businesses don't have a lot of data, right? But then on the flip side, somebody asked, what advice do you have for prioritizing data sources? They have hundreds of data sources, difficult to get to all of it. So 90% plus time is spent just trying to get the data. So take either one or take one of those, Tom.
Yeah, well, I'll take the data source one. I mean, the good news is, particularly with some of these auto ML tools, you can throw a ton of data into a model and see which ones are really effective predictors of your outcome. You don't have to decide yourself. So, now there may be some issues that involved in cleaning and integrating all of those different features or variables, but there's really no need to worry about, which ones are best. You just try them all.
Great. So we are at the top of the hour. So thank you, Tom and Alex, so much. Really interesting and informative talk. I know for people who were listening and watching, it went pretty fast. So the good news is you will be able to download the video of the webinar as well as get a PDF of the slides. And so over the next couple of days, look for an email. We'll have we also want to ask you to give us your feedback, really important to us to make sure we keep getting better. So we'll send that via email, and then also that will have a link to where you can access the video and the PDF. And finally, a big thank you to our sponsor, Cloudera, and for MIT Sloan Management Review for putting this on. Thank you.
Thank you so much.